Hi, you would have found that skills and maths very similar, but just a little bit more of understanding and you'll get it there. Now this is another sum that requires the same kind of skills, but just that it's a reinforcement. If you look at it, the model of the industrial estate is drawn at a scale of 1:50. And if the height of the buildings in this industrial estate in the model is 40 cm, find the actual height of the buildings in meters. They want to find out the height. Now, the floor area of each building is 2,800 meters squared, and that's find the corresponding floor area of its model building. Alright, so they want to find the model. Now, and then the last part comes the exhibition hall in the model is 960 cm cube. Now find the actual volume of the exhibition hall in meter cube. Now it's just a reinforcement to strengthen your skills and maths. Alright, and let's look at how you go from here. Let's look at it. Now the model, the scale is 1:50. That's the scale. And the height of the building is 40 cm. The actual height will be, alright, so we look at it here again, 1 cm represents 50 cm, right, 50 cm. And so if the height is 40 cm, 40 cm represents 50 times 40 cm. But I want to change it to meters, so I divide it by 100, and that will be in meters. Cancel, cancel. That's 20 meters. So we've got for the height is 20 meters. That gives us 20 meters. So the height of the building, all right, the height is 20 meters, the height of the actual building. All right, do you think that is really tall? What do you think is the normal height? The normal height usually is about 4 meters, all right, your home height. Some of the homes are getting shorter, 3.2 meters, and I don't know whether it goes below 3 meters, all right, maybe 2.87, I'd really wonder. But this is really a tall building, 20 meters, all right, the height of the building. But I suppose this is the height, when I look at the sum, whether it's the total height of that building, all right, that building, but how many stories we don't know. If there are 10 stories, oh my God, you divide by 10, then each floor is only 2 meters tall. But if there are 5 stories in that building, you divide by 5, then you get 4 meters tall. So that again left to be. But anyway, who bothers? Because the question is just telling you what is the actual height of that building. So you got to find out the actual height of the building, 20 meters tall. Now the floor area of each building is 2,800 meters squared. That is the floor area. Floor area is the space, all right, the floor area. Now what is the corresponding floor area of the model? So the scale. Now talking about area. What does in area? What do you worry about area? Okay, area. 1 represents 50. 1 cm represents 50 cm. Right? So 1 cm squared will represent how much? 50 times 50. Right? Which is 50 times 50 will give us 2500 cm squared. That is the representation. All right, every 1 cm, 50 by 50. Now the floor area here, this is the actual. This is the scale. What you're given is the actual, and you want to go to the scale. So what do? Well, now we put from actual, you want to move to scale. We say 2,500 cm squared. You are represented by 1 cm squared. And we're going to change this actual, you look at it, to meters. Or maybe you can even change that meter squared to cm squared, no problem. Alright, we look at this scale here. We are given 2,800 meters squared. Now how do you change 2,800 meters squared to cm squared? What is 1 meter squared? 1 meter is 100 cm. And 1 meter squared, 1 meter by 1 meter, 100 multiplied by 100, right? So let's look at this first from actual to scale. So what does 1 cm squared represent? 1 cm squared represent 1 out of 2,500 cm squared on the scale. Now how about, now let's look at this 2,800 meters squared. Now you want to change this 2,800 meters squared to cm squared. You multiply it by 100 and multiply it by 100, and that gives us 28. Let's put this way, 2 zeros, 2 zeros, 2 zeros is 10 to the power of 6 cm squared. So this is the flow area of the actual in centimeters squared. Now from here, you want to find out from the actual how much is that. So you put it down. Therefore, 28 times 10 to the power of 6 cm squared. Cm squared will represent, put this down and multiply it by 8, 10 to the power of 6. Alright, you can see that 10 to the power of 6, here is 10 to the power of 2. And what you've got here, you've got 28, and this is 25, and this is 10 to the power of 6, 10 to the power of 2, you take away. Alright, 10 to the power of 6, and here is 10 to the power of 2, 25,000. When you take away up, take away down, or you can cancel the zeros. For the lower ones, those are not very sure. Alright, you get 10 to the power of 4 because 2 zeros are cancelled off. So you can cancel that off and you get 10 to the power of 4. Now, you've got one, you can change it to decimal, 28 divided by 25. Alright, 28. Or you can use your common sense. Well, I know some of you don't like it. You get 1.12. So this gives you 1.12 and the 10 to the power of 4, and that will be in cm squared. Now if you were to change it, alright, if this is in standard form, if you want it in ordinary notation, you move 4 times, and that means 1, 1, 2. You move 2 times here, and not 2 times, and that will be in cm squared. Get 11,200 cm squared. Have you got it? Now what we do again? We said, hey, the flow area is 28,000, sorry, not 28,000, 2,800 meters squared. The flow area. You want to convert it to the scale. So what do you get? Look at this again. 1 cm squared represents 2,500, or you can put 2,500 cm squared. 50 times 50, 1 cm squared. Now look from area, actual, to scale, because you want to find the scale. So 25 hundredths is 1. Or you can put 2,500 is 1 cm squared. What is 1 cm squared from the area? It represents here. And what is this amount from the actual? Alright, because we had to convert this to from meters squared. We wanted to convert, let me write here, 2,800 meters squared. You have to find out how many cm squared it is. So that's why you have to multiply by 100 and 100. And to make it easy, if you put all the zeros, wow, you go putus. What's putus? Your break and burst, alright? So you want to make it easier. 2 zeros, 2 zeros, 2 zeros, you get 10 to the power of 6. And from here you find, alright, if 1 cm squared represents so much, what does this represent? Just got to multiply. And a simple logical reasoning. You look at that, 28 over 25 and 10 to the power 2, 10 to the power 6, 10 to the power 2, cancel off, you've got that wonderful answer. 11,200 cm squared. Now we're going to come to exhibition hole, the volume. The exhibition hole in the model is 960 cm cube. Find the actual volume in meter cube. Let's look at this and let me erase this part of it. Alright, we will move away from this A. Now this is volume, nothing. It's just that, you know what is so boring about scales and maps? It's just dry and just a lot of zeros and movement. But just get it going, alright? Please not all. This is just a little bit of a dry topic, alright? So just put a punch, have a potato chip with you as you eat, as you crunch, as you bite on it and enjoy your maths. Now the exhibition hole is 960 cm cube. Now what is this given? Cm. 1 cm represents 50 cm. So 1 cm cube will represent 50 times 50 times 50, right? 1 cm, 1 cm, 1 cm, the height. So 50, 50, 50. Can you tell me what will that be? Cm cube. That will be 5 times 5 times 5, 1 to 5, and you get 0, 0, 0, 0, 0, 0 cm cube. So 1 cm represents 125,000 cm cube. Now, the exhibition hole is 960 cm cube. You want to find the volume in meter cube. So what we need to do is going to change this to meter cube. So 1 cm cube represents, we look at this 125,000. We divide it by 100, 100, and 100, and we get meter cube. Alright? So we can see the 2 zeros here. We can cancel off the zeros. Alright? Cancel off one more zero. And what we've got is 125 over 1,000. So that is 125 over 1,000 meter cube. Alright, so 1 cm cube, I'm sorry, it should be cm cube, represents 125. If I divide by 1,000, I shift 3 places, 1, 2, 3, I shift 3 places, it will be 0.125 meter cube. 125, 0.125 meter cube. So what does 960 cm cube represent? It represents 0.125 times 960. Let's put the answer in the calculator, right? You look at it, 0.125 times 960. Ooh la la, wow, you get a simple, neat answer of 120 meter cube. Alright, 120, the actual volume. That looks a little small. Maybe it's a small hole here. The exhibition hall somehow, I don't want to go into the exhibition hall. Pretty small, 120 meter cube. Alright, but this I suppose is, we look at it, meter cube. Look at that. But this is what the sum is asking you. It gives you a visualization effect. You're able to visualize. Now, we look at exhibition hall again. We got 960 cm cube. That's the exhibition hall, the volume of that model. And the actual volume of it in meter cube. Now, 1 cm represents 50 cm. 1 cm cube is 50, 50, 50. You get 125, 000, which is 125,000 cm cube. You want to change it to meter cube. You see the number looks so big here. When you change to meter cube, they are the same size actually, but just another unit of measurement. You divide by 100, 100, 100. That's where you have to be very careful. Some of you tend to just divide by 100. It's not a length, it's a volume. So you got to remember that, please. So take off the 3 zeros here. You get 125 over 1,000, and then simplify it further, you get 0.125 meter cube. So what's 960? You multiply 125 by 960, that is the volume of this exhibition hall. Alright, how do you feel so far, skills and maths? Are you feeling comfortable? Good? Feeling reassured? Excellent. Alright, we'll move on to a little bit more difficult sum. Alright? And I'm sure you're an expert in it soon.